My name is Kendra Mellos, and I'm in the Palm Beach State College's Biotechnology program. My internship is at the Scripps Research Institute in Jupiter, Florida, in Dr. Laura Niedernhofer's lab focusing on aging. My project involves 4 drug studies to reduce cellular senescence to improve health span in a progeria mouse model. I'm currently genotyping primary mouse embryonic fibroblasts for ERCC1-, which will age quickly for drug assays. I'm cleaning the bench area with 10% bleach and 70% ethanol. I'm using 100 microliters of alkaline lysis reagent to add to each tissue sample. Then I vortex all of the samples. I take all of the samples and I place them into a shaking incubator set at 95 degrees Celsius for 30 minutes. While my tissue samples are incubating, I prepare for the following steps. In an Excel file, I enter the N number of samples, including a het control and a non-template control. Then I make a complete master mix using distilled water, master mix, and a primer mix. I use the Excel printout that gives me the exact calculations on how much of each reagent to use. Make sure to keep the complete master mix on ice throughout your experiment. I'm adding 100 microliters of distilled water into new microcentrifuge tubes. A neutralization buffer is needed to stop the reaction after the 30 minutes of incubation at 95 degrees Celsius with the lysis buffer. After vortexing all of the samples with 100 microliters of neutralization buffer, I add 30 microliters of each sample into the 100 microliters of distilled water. Then I add 23 microliters of the complete master mix into the wells of the PCR strip. Then I add 2 microliters of DNA into the wells of the PCR strip with the complete master mix. After sealing the PCR strip tightly, I vortex it and then put it into the centrifuge. Then I place the samples into the PCR machine, select the open method, then the ERCC1 option, the block, and then start. I bring the running buffer up to the max fill line and vortex the latter. Then I add 10 microliters of the latter to a fresh microcentrifuge tube. Then I add 2 microliters of Easy Vision into the latter and 4 microliters into each PCR product. After adding 5 microliters of the latter into the gel, I add 13 microliters of the DNA PCR sample into the wells. After the 2.5% agarose gel has ran for 35 minutes at 120 volts, I bring it over to the UV dock. Don't worry, there's no ethylene bromide in the gel. Turn on the UV light, open up the system, and I click Live Feed in Ethylene Bromide dropdown, and then Acquire. Then I invert to the black and white version and analyze the data. Our data shows that we only have heterozygous samples and wild type.